I'm just using my colleague's slide here. I'm presenting our CubeSat CUAVA-1, our Pathfinder satellite for remote sensing and Earth observation, and in this context also how we used Rust in our development. So first about the CubeSat and the mission a bit. It's our first CubeSat, obviously CUAVA-1, and we're flying the first generation of instrument sensors that are built explicitly for our satellite from our partners at the University of Sydney, at the University of New South Wales, and Macquarie University as well. So getting all the universities in, or a lot of universities in Sydney, basically together. So here's a nice overview about our 3U CubeSat. We have the satellite bus here at the top end, underneath the UHF antenna. All of the stuff is commercial off the shelf, and we just wrote the software for it. And then our payloads is here a GPS receiver from the UNSW, and ISTI, that's a combined payload doing hyperspectral imaging, and there's a little Tollyman experiment on it as well. That's a telescope. And then we have the Rush payload. I don't necessarily know what they do. And we have the radiation counter and data over power over data bus experiment. That's really nice and shifty, using very low power connection to run this experiment. And all our external solar cells are also commercial off the shelf, and we're actually missing one because one of our we had a supply issue there. Yes, and for the ground station, it's a joint effort with our partner Sabre to get the communication with our satellite that's in space to run. About the software and the testing, the flight software for our CubeSat, we used the Kubois open source platform. I believe that Adrian talked about this in the last AeroRust meeting. So it's an open source platform developed a couple of years ago, many years ago, well documented, and provides all the application programming interface for the subsystems. It comes already with a file transfer protocol, which is really handy. And for most part, the communication is based on HTTP and the GraphQL interface between the systems, subsystems, and also between ground and the satellite. For the testing, we had the flat-set layout, as you can see down here, where we did all our software development and the functional tests for all the subsystems. And we also started doing the RF tests for the antenna in our lab before we went out. So the good thing about the Kubois platform here for our software development and the functional test was through the GraphQL, you can directly just send a GraphQL request on your computer and get a reply from the satellite that is humanly readable, which is very nice. Oh, all right. Actually got a video there. So that's actually the testing of the ADCS. You see the satellite here turning on the turntable. Yeah. All right. We obviously then also did some environmental testing with our satellite, and everything was integrated. That was at the AITC in Canberra. Did the necessary vibration tests and the thermal cycles there. And that's our satellite ready for shipment. That was now half a year ago. And we launched it with JAXA or Space BD, who worked with JAXA, and then it got launched on the Dragon resupply mission for the space station, CRS-23, in late August. And now 1 month ago, on the 6th of October, I think, it was launched from the ISS, from the JAXA JSOT, their CubeSat deployer, into space. And yeah, so far it's been 4 weeks. Unfortunately, we haven't heard of it, haven't received any signals. We don't know what is wrong. There's many things that could have gone wrong. And there's many things that we can maybe do for the development for our next CubeSats to mitigate those problems. But yeah, because we don't have an idea, or we don't have any communication, we don't really have an idea what's the error. It's a little bit, yeah, but we're still working on it, trying to recover it. There's a couple of ideas we still haven't tried. Yeah. All right. So as all this is happening, trying to get the communication with our first satellite to work, or at least hear a signal of life from it, any kind of beacon that is running on it. We're also already working on our next satellite, CUAVA-2, which will be bigger than the first one. It will be a 6-unit CubeSat. The bus will be mostly the same parts as for the first one, just with some upgraded ADCS. Especially we're getting, so on CUAVA-1 we only had 1 reaction wheel, and now on CUAVA-2 we're going to have 3. And we're adding a high-speed comms, so an S-band transceiver on CUAVA-2 as well. The software should mainly stay the same, the Kubois platform. And so all the testing and debugging that we've been running now to try to recover CUAVA-1 also helps already in the CUAVA-2 design, and maybe even then the next satellites. The ground station is going to be the same as before as well. And the high-speed ground station, we're going to go for some commercial AWS or something like this to work with those. Still, all our frequencies will be in the amateur band, so amateurs can listen to it. We have CUAVA-1 is on SatNox. The decoder for the beacon is available on SatNox as well. So yeah, and we got great help from them listening, trying to listen to our satellite as well. And yeah, also on CUAVA-2, all the experiments will fly upgraded experiments, but other than that, it's pretty much similar payloads, all research from the University of Sydney and our partners from UNSW. Okay, I think that was it for, yeah, this one. I have another little can you see my screen? New presentation? Okay. Good. I also want to talk a bit about Kubois and Rust, since this is the AeroRust meetup. Although I think that Adrian told you a little bit about it last time, like I said. General Kubois is a Linux-based OS, well documented, open source, of that we said already. The software architecture is built in a way that we wrote our mission applications. They're made by us. The Kubois services, at least the core services to interact with the satellite, they are built by, the core services are built by Kubois on top of their Linux distribution. And we build our own APIs and services for all the commercial off-the-shelf bus products that we used. And yeah, the OBC that we used was the ISIS OBC, IOBC. Yeah, very old ARM chip from about 10 years ago with a lot of flight heritage. And yeah, generally the Kubois system supports Python and Rust, but because the IOBC doesn't support Python, that's the main reason why we originally went with Rust. And yeah, 2.5 years ago when we started the development, basically nobody in our team had ever touched Rust before, and it was a very steep learning curve the first couple months to get those APIs and services running, to learn Rust in the first place, and then use it. But it was, yeah, it was a challenge, but we got there. Yeah, so there's a lot of things that Kubois already provides. The main things are the hardware abstractions, I2C, SPI, UART, all those things are available from them. The APIs for the external devices, there's a couple of yeah, APIs available for some commercial off-the-shelf products, and we had to write our own mostly. But we share, or our plan is to share everything that we wrote with the Kubois community as well, which is a bit of a different problem, but to that later. Yeah, the services are mostly for the ones for our payloads and the bus. It's all written by us. As I said, they all interact with each other. Oh, sorry. Via their HTTP server endpoints, which accept the GraphQL requests and return a JSON response. And yeah, we have those three kinds of services: the core services that were written by Kubois, and the hardware services for the bus systems that were mainly written by us, and then the payload services written by the payload teams actually. Yes, then the next thing above those services are the mission applications, user level programs. You can actually say, do this, do that. You can command the services via GraphQL requests to do the what you want. And then a couple of protocols that come in handy that are already part of Kubois, the file protocol and the shell protocol that lets you send, well, you can send a command, and shell actually, it's like you're using your normal Linux, can just send Linux commands up to the spacecraft and they get, yeah. Yeah, so GraphQL, in a sense, especially for debugging, it's very nice. You just sit there on your laptop right next to your CubeSat, run your software, and you have those nice GraphQL queries or mutations, and get a reply, and it's humanly readable, and you know what your software has been doing, or what your satellite is up to. Yeah. To be honest, I'm a big fan of the debugging functionality. I'm not a big fan of the huge overhead that GraphQL poses onto the already limited capabilities of our OBC, in terms of processing power, and also on the ground link, because you just want to send here a little ping command, for example. Not there, but the ping command would be just, oh, you send 1 byte command up, instead, because everything is in JSON. It's a big string, and it's suddenly one ping command becomes 40 bytes instead of 1, and it's just a bit. That's the very extreme example, but yeah, basically you're sending all this data when it's enough to send your timestamps and everything, and you know which bytes are what. Yeah, and yeah, like I said, I mean, okay, that's just the end of that then as well. So basically, for our next CubeSat, I'm working on getting rid of the GraphQL and replacing it with a simple UDP handling system. And we're also working together with the Kubois community. That community at the moment is just a Kubois preservation group run by Adrian. I've been in some talks, trying to revive that a bit. We want to share all our software that we've written so far, and we're happy to help maintain that community, because we're interested in using Kubois throughout all our missions in the future. Because we're already committed to the system. We spent so much time developing stuff for it. And yeah. All right. I guess I can end that for now. Oops. And stop sharing my screen. All right. Thanks. Okay. Are there any questions?
Yeah, I can definitely ask a question, because Kubois seems really interesting, especially for, I guess, universities. And developing such a project through Kubois preservation group seems reasonable, because it's helping a lot of the how to say it, the academic work. Yes, definitely. That was the word I was looking for. So,
Yep.
how do you think we can further develop Kubois to have a more broader ecosystem? Because you're making code that can be applied to Kubois and maybe open source, but how we can do this in the long run, basically, to have some sustainability.
Yeah. Well, the first thing we need is people that collaborate. Obviously, Kubois itself is otherwise very nice. Like it's been out there for a longer time, but yeah, had a couple of problems in the recent years, since COVID basically, with maintaining that stuff. But generally, yeah, just trying to get that community running, give people a very easy start to it is probably the best way to, yeah, get more people involved.
Mhm. Okay.
And yeah, there's a lot of things to be done, but we have to go step by step. And one thing for now is, if we can just publish our code and open source that, um, yeah, and all the new stuff that we're writing right now for the new missions as well.
Mm.
One one big problem always, I think that's mainly a problem in the space community, is that as soon as somebody hears the word space in any kind of topic about it, the government is always like, what's happening? We need to protect this. The military, it's very easily under military restrictions, and that's really annoying. But gotta live with it, and gotta see how we can deal with that situation. But most of the stuff that's not mission critical is easily open sourced normally.
Mhm.
Yeah.
Okay. And you mentioned something about the GraphQL and that it's heavy using JSON responses
Mm-hmm.
and GraphQL requests.
Yeah.
What kind of alternative are you looking for? Because I can tell you from top of my head, like Saturday has like a few binary formats that you can use,
Yeah.
but maybe
Yeah.
you need something with parity bits at least to protect yourself from bit flips
Yeah. So
during
well,
communication.
the main thing is that, so on top of all that GraphQL, there's always the CubeSat space protocol, like everything on top, and then that's one layer, and then there's also the AX25, the amateur radio frame. Like it's also packed in that frame as well. So there's a couple of protection layers that have like methods to check for bit flips and other things. That's mostly in there, done by the radio, and by the way that is handled. And yeah, so for the data itself, what we're looking for, or what I've actually been doing for the last couple of months now, is I'm using bin code from the static crate, but I adopted it, and I wrote my own procedural macro using that, because it lacks one fundamental thing that we need, that is the check for a specific length. So our data input is only supposed to be 5 bytes long, but bin code, the deserializer, can deserialize anything into 5 bytes as long as it's longer than 5 bytes. But we want to only deserialize exactly 5 bytes into that structure, for example. And so I wrote a procedural macro for that based on bin code. And I'm working on on the next iteration of that macro at the moment. to see if I can improve it a bit. But generally, it works. You can import this one I call deserialized sized. You only need to import also serialize and deserialize, and then you can work with that. Yeah, in a way that's sort of intended.
Okay, nice. Yeah, I guess you can always make like an abstraction, for example, to always send 5 bytes, and then at the end just combine them all together and deserialize the whole struct.
Yeah, it's I mean, depending on what structure it is, like I'm really looking at the size of the structure, see how long it's supposed to be, and if the input array is the right size, and yeah, so that works really well so far.
Okay, seems interesting. Yeah, and Adrian actually didn't make it to the last meetup, but he shared like a document with a lot of information about Kubois.
Yeah,
So that was helpful, definitely, and I like it. So
yeah, yeah. Now we had a meeting with him, I think 2 weeks ago, talking about what we can do, and wrote out 2 pages of stuff to do. But yeah, there's a lot of work and not many people and not much time. That's
yeah,
the main problem.
yeah, definitely. Oh,
Yeah.
well, that's all my questions that I have for you.
All right.
If somebody else wants to join, like Sebastian, if you have any questions.
I was just about to say I actually worked on integration with both.
We can't hear you very well. Can you turn on the mic a bit more? Yeah.
If you have anything, post it in the, yeah.
Hi, can you hear me?
Yeah.
Yeah.
Better.
Okay, perfect. So actually, I interned 2 years ago at NASA IVNV, and we actually worked with Kubois a little bit. It's interesting. So at
right.
this facility, we were working on something called NosCube. I don't know if you've heard of it. It is a software-only simulator for CubeSats. So basically, it'll simulate orbital mechanics, everything that a real space environment would have, and you run your flight software, and it thinks it's running on a real satellite in space. So it's a great way to test your flight software, before you actually have perhaps the hardware and the means of testing it, which could save time and money. But anyhow, I was tasked with integrating Kubois into that framework such that you could run Kubois in that simulation environment. So I thought that would be interesting to tell you guys, since I saw you were going to talk about CubeSats.
Nice. Did you succeed?
Yeah,
Setting it up?
yeah. It was merged into the Kubois master branch, the libraries necessary to do it. So yeah.
Nice.
I don't know if anyone's actually used it, but it's out there.
No idea. I've never heard of it, and it's never really or I've never seen it mentioned anywhere on the Kubois in all the documentation or anything.
Yeah, I can get you a link.
That's quite interesting.
To the project here.
Yeah, and actually, regarding the deployment of the satellite, I had another question that I forgot to ask. It wasn't there like an extra step that they can make before they actually deploy the satellite outside of the space station, just to check that the hardware is working? Otherwise, maybe it doesn't make sense to deploy it anyway.
Not really, as far as I know. It's just on those I guess all they're doing is they remove the remove before flight stickers. No, that's actually still done on the ground, and it's just put into the pods, and then you just have to see if it works or not. It's a bit generally a bit unfortunate, I want to say, on our side. Out of the 4 satellites got launched, we're the only one that haven't made contact yet. But yeah, I don't really know what happened. There's too many things that could have gone wrong.
Yeah, no worries. You'll make it the second time, you know.
You're muted at the moment.
Oh, I said that you're going to make it the second time, right?
Yeah, sure enough. Now there was a couple of things. Or we had some weird errors with the EPS sometimes. That's one of the main things that we worried it could have gone wrong. Is sometimes the EPS or the OBC doesn't come up when it tries to start in sunlight, because the EPS gets some weird signal through the solar cells, and that prevents the boot. It's very obscure, and we don't really know why that is happening. But we observed that a couple of times testing on the ground, and we fear that could be something that could have happened.